Good morning, this is David Johnson. I thought I'd do a very short tutorial on analysis methods. I feel the Collier default is not really ideal for most composite analysis. And what I'd like to do is help the very beginner type guy that has difficulty choosing these defaults. I won't go into an explanation of why I've chosen these. What I would suggest is that try these out and do your research. And I'm basically pointing you in the right direction here to select the failure modes for most composite type structures, both skin stringer and also for the honeycomb structures. Now, analysis methods, we can set a default for in our template, so you want to set this default in your template as a template tutorial. To get to this analysis default screen, you simply go to preferences. So buckling of beams, a beam probably being a skin stringer configuration. I would just simply select the flexural torsional and the initial imperfection. The initial imperfection, you put the number in here on the free body tab. This is where you click this button and put the number in here. Also, the flexural torsional, most panels of any length for a skin stringer, for an open section, this will probably be your critical mode. Flexural torsional. An open side, say a Z stringer or any type of stringer that's an open section, it suffers very badly from a flexural torsional perspective. Now, most people wouldn't do this hand analysis, but ironically, this is probably your critical failure mode, assuming you've got quite a large span. Buckling local, this is just for the skin panel itself between the stringers, just a local buckling of a quad element. You want to pick biaxial with shear interaction. Just this one alone here is more than adequate. Panel buckling. This is where you have a panel, say on a wing between two ribs, and you have several stringers. This is buckling of the whole panel. And more often than not, this panel buckling energy solution, or BC, is probably the ideal. There are a few other options that you could try. Buckling of the stiffener. This stiffener buckling, flexural torsional, is probably the correct option. Crippling, now we're talking about composites here. Of course, if you work at LTV, this is the one you pick here, but for most of us, we're going to pick the MIL 17 handbook, ultimate failure only, and we probably might pick this buckling interaction with Johnson Euler. Deformation options I've left and frequency options I've left out. Geometry checks, I don't really want to go into that. I think that's a specialist topic in itself, but I'd probably go with the Collier default option of number 40. Joints, I'd ignore all joints. I still think that's a preliminary analysis method for Hypersizer. Strength, now we have laminate strength here and we have ply. I prefer laminate, but I'm not going to discuss that today. Most companies, for some reason, use ply-by-ply analysis, but I still don't think that's a good option for damaged panels, but this is what we do. And the best process is to use the max strain method. Max strain 1, max strain 2, and shear 1, 2. The other methods can be used, but they cause problems when you're trying to correlate the allowables. And then sandwich structures, I would pick wrinkling equation 1 and 2. I would pick the dimpling equation. I would do flatwise if you have a curved panel. And you may choose to have flatwise with an in-laminar shear interaction because there's two things going on at the same time. That's a specialist topic in itself. You need to be very careful if you have out-of-plane loads on a curved sandwich panel. Shear crimping can occur. And then shear strength for the core in the X and Y direction. Most companies just write margins just for the X direction and Y. If you wanted to have an interaction equation, you could use one of these equations below. Stiffness we're not going to discuss, and then user-defined, you have all these user-defined analysis. Obviously we haven't set any up. So in conclusion, if you set off with those items and put them in your template, for most beginner guys, that's going to get you in the right ballpark. Those are the analyses that you need to do for composite analysis. Very short, just trying to help out. So thanks very much and have a good day.